Hi class, this is Professor Latham. I'll be doing part 2 of the movie on computing the sample correlation coefficient. In this particular problem, we can see that we have the column data for the height and also the column data for the height of the sun. But we also have the product. In other words, if you multiply this number times this number, it will equal 32906.25. But they've done the computation for us, so that's really cool. So when we swing down to this particular problem, they ask us, here's Sir Francis Galton, and he was the first to introduce the statistical concept of regression and correlation. And he studied the relationship between pairs of variables such as the size of the parent and the size of their offspring. And here's the data that we have below. When we look at the data here, we can see that it's kind of going up on the roller coaster. Like the last data set, the values were going down. So we would say it looks like it's a positive linear correlation. And so we want to see, well, how positive is it? The closer these dots are to lining up perfectly, the closer the R value will be equal to 1. If it were the decreasing case, it would be negative 1. Alright, so compute the sample correlation coefficient. So when we look at a list of formulas, it's going to ask for a bunch of data. So let's go ahead and click on that so we can see what exactly we'll need for this particular problem. So here is the linear correlation coefficient. It's R. That's B1, the slope. So here it is, sample correlation coefficient. So you can see when we click on the shortcut formula, we need the summation of xi, yi. So that little letter that looks like an E means summation. So that means first take the product and then add them all up. Then we need n, that means the number of pairs of data. Then we need x bar, which is the sample mean for the x values, so that's the heights of the fathers. And then we need y bar for the height of the son. And then we need the standard deviation for the x column and the standard deviation for the y. So we basically need 5 different creatures. 1, 2, 3, 4, 5, actually 6. So let's go ahead and use Word to capture all the pieces of the puzzle that we need. So here we have the value of R captured in our Word, actually equation editor. So you can see in finding the sample correlation coefficient R, we're going to need the summation of xy, so I need that xy column, add them all up. I'm also going to need n, so there's n. I'm going to need x bar. I'm going to need y bar. I'm going to need s sub x and s sub y. So I need all those values in order to compute the sample correlation coefficient. You know what's funny? In the old version of Alex, the calculator could store several values, and you could just keep all the values stored, and you would plug them in order. But I don't know. Maybe somebody didn't like the fact that you had. Oh well. Anywho, I thought that made more sense. All right, so we need all these. Summation xy, we need n, we need x bar, we need y bar, and s sub x and s sub y. So let's go ahead and have at it. So we're going to take this column here, that's the summation of xy. We're going to highlight it, and that'll populate the calculator. So we have all the values there. We went all the way to, oh no, we don't have them all. Yeah, so we have the first one, 32906.25, and the bottom one. Yep, there we go. All right, so that's the XY column. Now we're going to take the sum of it. So that's going to give us 5, that number there. So I'm going to go ahead and copy that by using Control C, and I'm going to paste that into Word so I don't lose all that, just like you would write it down on a piece of paper. All right, n is the number of pairs of data, and so if we look at the pairs of data, they tell us that there's 16 pairs, or you can actually count them. So n is going to be 16, so we'll capture that in Word. And now we need x bar and y bar, so how do you think we're going to do that? Yes, we love our little calculator. I guess I could store one of these. Oh well. All right, so we'll go ahead and highlight the x column. And then we'll go ahead and find x bar, which is 180.525. So I'll Control C, copy that. All right, and clear that out, and then highlight. Oh, you know what I should have done? Bummer. I should have found S of x. It's all good in the neighborhood. Okay, so we'll go ahead and highlight that, and we'll find x bar again. Since it's the y column, though, it's not x bar. That's y bar. So I'll copy that. Now I'm going to go back and hit that undo button. So I'm going to hit undo, and that's all the data values, and hit S. And I get 8 point. And this one's probably again to 4 decimal places, and then round to 1. That was y, though. That was S of y. Remember, I went ahead and had the y bar, and then I said, well, let me go ahead and capture S of y. Now that's weird. Last night when I copied that code, I got all this other stuff. That was weird. Maybe a different type of problem. All right. Now let's go ahead and do the same thing for the x column. Find the standard deviation for that. So I'll highlight the x column, hit S, and that gives me that number there, 14.1 and some change. So now we have all the values. So we can go ahead and compute R. So I'm going to go back to Alex and click on List of Formulas. That's B1. Remember, that's the slope. And R is the sample correlation coefficient. It would be helpful to hit the right guy there. All right. So now we have it. So we just plug in our values. So what I'm going to do is I'm going to shrink the screen so I can see them both at the same time, so I'm not having to travel back and forth between the two documents. All right, so now we can go ahead and plug and check. So we've got 52.40.59. N was equal to 16. X bar was 180.525. Y bar was 181.5356. N again, 16 for this number of samples. The sample standard deviation S of x for the x column, 14.1686. That's 4 decimal places. 1686. And 686 and 8.4592 decimal places. All right. And so we have all our values. So let me just double check just to make sure I got everything right. So 52, 40.59, 16, 180.525, 181, 35, 625, 16 and 14.1686 times 8.492. Perfect. I'm sorry, I didn't pick up the mic again. So let me start all over again. So I'm double checking. I just put in all those values into the calculator. 52, 40.59. 16 is the sample size. This X bar was 180.525. Y bar was 181.35625. The S of x is the sample standard deviation for the x values, and we have that captured here, and that was S of y. And so we get a positive number, is what we would expect, and it's 0.78. It's close to 1. .78, and they want us to carry it to 3 decimal places, so 0.785. 0.785. All right, well, I hope this movie will help you with computing the sample correlation coefficient and for the least squares regression line. If you have any questions, feel free to call me at 813-9027. Thank you. Bye-bye.